Okay, so let's get right into it. Have you ever looked at a chemical formula and felt like you were trying to read some kind of secret language? Well, you kind of are. But here's the good news. It's a code that is super, super easy to crack. And today, we're going to break that code together so you can name these compounds like it's second nature.
We'll start with one you've definitely seen before. We all know this is carbon dioxide, right? It's what we breathe out, what plants love. But have you ever actually stopped to ask why it's called carbon dioxide? I mean, why not just carbon oxygen? There's a reason, and it's simple.
And then there's this guy, N2O4. I know, it looks a lot more complicated, maybe a little intimidating, but I promise you, by the end of this, the system we're going to learn makes naming this one just as easy as our old friend CO2.
So what's in a name? Well, in chemistry, it turns out everything. And thankfully, it's not random. There's a simple, logical system, like a recipe, that we can follow every single time. Now, the official term for what we're naming is a binary covalent compound. Whoa, that sounds like a mouthful, but don't let the fancy words scare you. Let's just break it down. Binary just means two. That's it. So we're talking about molecules made from exactly two different nonmetal elements. Think carbon and oxygen.
So, what is the big secret to cracking this code? It all boils down to one simple idea: counting. That's it. The names are just a set of instructions that tell us two things: which elements are in the molecule, and, this is the important part, how many atoms of each element are there. And how do we count in chemistry? Well, we use a simple tool: prefixes. These are going to be your best friend. Once you know just a handful of these, you are basically already there.
And here they are. This is pretty much your cheat sheet for naming these compounds. You've got prefixes for numbers 1 through 10. For today, pay close attention to di for 2 and tetra for 4. You're going to see those pop up in just a minute.
All right, so this whole system really just has two main rules. Let's start with the absolute easiest one. It's all about how the name ends. Here's the rule. You take the second element in the formula and you just change its ending to "ide." So oxygen becomes oxide. Simple. Chlorine becomes chloride. You see the pattern? It's that straightforward every time. Okay, on to rule number 2. This is where we bring it all together. We're going to take our prefixes from the cheat sheet and that "ide" ending and build a full name. And we'll start with CO2. So first things first, let's break CO2 into its two pieces. On the left, you've got the C, that's our carbon, and on the right, you've got O2, which is telling us we have 2 atoms of oxygen. So, just putting that into plain English, we're working with 1 carbon atom and 2 oxygen atoms. Okay? You with me? Now, let's actually build the name from these parts. Here's how we put the puzzle together. Step 1, we always start with that second element, oxygen, and we change its ending to "ide." So, boom, it becomes oxide. Step 2, we look at how many oxygen atoms there are. There's 2, right? So we grab the prefix for 2, which is di. That gives us dioxide. And for the final step, you just stick the name of the first element, carbon, right on the front. And there you have it, carbon dioxide. See? Simple recipe. Now you might be thinking, hey, wait a second. There's only 1 carbon atom. Shouldn't it be monocarbon dioxide? And you know what? That is an excellent question. But here's the one little exception to the rule. Chemists like to take shortcuts, so they almost always drop the mono prefix when it's on the first element. It just keeps the names a little cleaner. Okay, you've totally got the basics down. So let's go back and tackle that tougher-looking formula from the beginning, N2O4. This time, we're going to need to use a prefix on the first element, too. So let's decode it piece by piece. First up, we have N2. That little 2 means 2 nitrogen atoms. The prefix for 2 is di. So that part of the name is dinitrogen. Next, we have O4. That's 4 oxygen atoms. The prefix for 4 is tetra, and of course, oxygen becomes oxide, so we get tetroxide. Now, you just smoosh those two parts together, and what do you get? Dinitrogen tetroxide. See? It doesn't matter if the formula looks complicated, the rules are exactly the same every single time. All right, your turn. Time for a little pop quiz to see if you've got it. What is the name of PCl5? I'll give you a second to think about it. You've got 1 phosphorus and 5 chlorines. What's that prefix for 5 again? Did you get it? It's phosphorus pentachloride. Penta is our prefix for 5, and chlorine becomes chloride. And notice, we didn't say monophosphorus, right? Because we skipped mono on that first element. You nailed it. So let's just do a super quick recap of the whole system. For that first element, you use a prefix, unless it's mono, and then just say its normal name. For the second element, you always use a prefix, then the root of the element's name, and you always end it with "ide." That's the whole game. And that's it. That's the entire secret code. You seriously now have all the tools you need. You can look at any binary covalent compound and you can name it with confidence. You've got this.
So, we've cracked the code for what we call these things. But a name is just a name. It doesn't tell us about a molecule's shape, which is absolutely crucial for how it actually works in the real world. So now that you can name them, what do they really look like in 3D? Well, that's a great question for next time.